Hello everyone, myself Chandra Shekhar welcoming you all once again to this faculty driven platform that is Resultant. So in today's discussion, I will be talking about an important and interesting concept of fluid mechanics, or we can say from the manometry. First, we will have the practical demonstration and we will find some observation, and then we will try to analyze through the conceptual explanation whether our findings are related or justified with the conceptual explanation or not. So let us have the practical demonstration first. So in this demonstration, what I am having today is a tube, an open-ended tube, a tube which is open at both the ends, right? Now, if I pour some liquid in this tube, and then we will try to observe what is going to happen. Let me pour some liquid in the U tube. Look, now I have poured some liquid in this. Can you see it? It is a colored liquid. It is a kind of U tube, U-shaped tube. The shape is U. So as long as both the legs of this tube are open to atmosphere, then the level of the liquid in both the limbs is same. Can you see it? The level of liquid is here. In both the limbs, it will be same. Even if I move one limb higher than the other, like this, do you see any change in the level? Do you see any difference in the level? Even if one limb is higher than the other, there is no change in the level of liquid in both the limbs. Even if I make the other limb higher and the one limb lower, you can see there is no change in the level, right? But if I close one of the limb with my thumb and then the level is slightly different, the level is not same. One limb is open to atmosphere, can you see it? And the another limb is closed. Even if the height of both the limbs is same, then you can still see the difference in the level of liquid. If I move one limb higher than the other, then the difference in the level will be more and more. More is the difference in the height of the limbs, more will be the difference in the level of the liquid. Now, if I remove my thumb to make it again open to atmosphere, then what will you observe is the level of liquid in both the limbs again becomes same. So if I close one of the limb with my thumb, then you can easily see the difference in the level. You can easily see the difference in the level of the liquid in both the limbs. And as soon as I remove my thumb like this, as soon as I remove my thumb, you can see again the level in both the limbs become equal. Let us try to understand this through the theoretical explanation. So this is how this is happening. Can you just let me know through the comment section, everybody? Do you have any idea how it is happening? Look, the concept is justified, the observation is justified through a very beautiful and interesting concept of fluid mechanics that we call as Pascal's law. So Pascal had given a law related to the static fluid. What the law stands for? According to Pascal's law, if there are two or more points at the same elevation, means same height, in the continuous mass of same static fluid, they will have same pressure. So there are Three conditions: same elevation, continuous mass, and static fluid. So if these three conditions are getting satisfied for any fluid or any points lying in the fluid, then the points will have same pressure. So these are the conditions. Same elevation means same height. Then continuous mass means single fluid. The point must be part of the single fluid. And the third is the fluid must be static. It should not be in motion. It should not be in the flow. Then they will have same pressure. So out of these four conditions, we can call them to be four conditions. Out of these four conditions, if any three conditions are getting satisfied, then according to Pascal's law, the fourth condition will also be correct. Let us try to understand the U2 manometer. The manometer, which is having the shape of a letter U, alphabet U. So as long as both the limbs are open to atmosphere, we can say the pressure in both the limbs is PATM. The fluid is static. This is static liquid. So if we talk about these 2 points 1 and 2, if you observe these 2 points 1 and 2, what we will see? These 2 points are part of static fluid. That condition is satisfied. These 2 points are part of a single fluid, because if we join these 2 points, we can join them in a single fluid. From the bottom, it will be a liquid. From the top, it will be air. So either from top or from the bottom, we can join them with a single fluid. Second condition, single fluid or the continuous mass is also satisfied. Now the pressure in both the limbs, or P1 is equal to P2 is equal to PATM. The pressure at 1 and 2 will also be same. So according to Pascal's law, the remaining condition, that is they will lie in the same elevation. The points 1 and 2 will be lying in the same horizontal plane will also be true. This Pascal law has nothing to do with the geometry of the tube or area of the tube or size of the tube. It has nothing to do with the geometry, area, size. It only talks about the four conditions which I have already told you. Even if the area of both the limbs are not same, still, as long as both the limbs are open to atmosphere, as long as both the limbs are open to atmosphere, the level or the point 1 and 2 will still lie in the same horizontal plane, because these 2 points are satisfying all the conditions of Pascal's law. Now, if the pressure is not same, what will happen if we change the pressure in any one of the limbs? As long as P1 is equal to P2, both the limbs, then the level of manometric liquid will also be same in both the limbs. That is what I have already told you. Now if we increase the pressure P1 or if I decrease the pressure P2, so there is a difference in the pressure in both the limbs. So by increasing the pressure P1, then the high pressure will push the liquid in downward direction, or the low pressure in right limb will pull the liquid in upward direction. High pressure in the tube will push the liquid in downward direction. Low pressure in the tube will pull the liquid in upward direction. So there is a deflection in the liquid. Can you see it? So by seeing the deflection, we can easily say which limb is having more pressure. Are you getting it? If P1 is decreased and if P2 is increased, if there is a difference in the pressure in both the limbs, if we increase the pressure P2, again due to increase in pressure in right limb, the manometric fluid will be pushed downward from the initial level. This was the initial level when the pressure in both the limbs was same. When P1, the pressure in the left limb is decreased, then the liquid will be pulled in that limb in upward direction. So low pressure will pull the liquid and high pressure will push the liquid. So there is a deflection in the liquid. So that is how we can explain our findings, our observation using the Pascal's law. I hope you understood the concept. So this is all from my side for the day. Take care. stay safe, stay motivated, and keep preparing for your upcoming competitive examinations. See you in the next such video. Till then, enjoy, take care, have a good day, and a great career ahead. Jai Hind.